All right, we'll go ahead and begin. Good morning, afternoon, or evening, depending on where you are. Thank you for joining us today. Welcome to the first webinar for the Sustainable Design webinar series. My name is John Harridge with Autodesk, and I will be the host and moderator for today's session titled Sustainable Buildings, How to Integrate Insight into the Design, Build, Operate Lifecycle. A little bit about myself and my role as a technical marketing manager. I create learning experiences to inspire the next generation of designers, engineers, and builders to create a better world through the future of making things. Today, I'm delighted to be joined by our guest speaker, Ian Malloy. He is a senior product manager for Autodesk Insight. As the need for sustainable buildings increases globally, educators are seeking new ways to help students solve these important building challenges for their own projects. This webinar aims to help educators and architectural students devise a strategy to integrate outcome-driven insight into their design process for application in design studio projects and onwards into professional life. So here's a look at today's agenda. Ian will begin by describing the Design Build Operate ecosystem and then move into the concepts of building energy modeling. Then discuss key technology trends that Autodesk is leading, followed by learning resources and Q&A. So if you are new to BIM or Autodesk Insight and looking for ideas on how to integrate Insight into the design process, you have come to the right place. Ian, the floor is yours.
Thanks, John. Hi, everyone. It's great to talk to you here today in the first of these Sustainable Design webinar series. I'll just start a little bit about me. As you can see, I'm the product manager for Autodesk Insight, which is essentially all of Autodesk's building performance analysis tools, covering things like energy and daylighting and thermal comfort and so on. My background actually is in mechanical engineering and building science, and I've been developing tools like Insight and applying them to the whole building life cycle for pretty much my whole career now, over 20 years now. So I'm delighted to talk to you here today. I've got a presentation that I've given in various contexts before. I've adapted it a little bit specifically to focus on a few key things I want to leave you with today. But hopefully, what this will do is give you a good picture of at least how we at Autodesk see sustainable buildings and the opportunity to do better, essentially build them better, design them better, and operate them better. I'm going to cover a lot of ground in terms of overall technology, where we're at, and some of the key tools that we're both continuing to develop, and seeing a lot of success in the industry and in education and the adoption of to help with achieving those goals of better buildings. Okay, so John, just let me know this slide moves forward, okay?
Yes.
Great, thank you. Okay, so just a little bit of context. So the thing I want you all to think about is this. So when we talk about sustainable buildings, I mean, just do a Google search for the most sustainable buildings, and you see something like this, right? And we all have a picture in our mind of what sustainable building is. There are numerous standards and codes that you can look to define what that is. I mean, it's very much an evolving and nascent space. It's growing very rapidly. The need for this is becoming more and more apparent, as time goes on, and the business benefits of it are becoming more and more apparent. But the important thing to highlight, and it's a sort of a simple trap that we all fall into too easily, is that when we think of sustainable buildings, we think of these really high-end, high-profile buildings that are really at the bleeding edge of sustainability. And in any transformation, market transformation, it's really important to have those flagship projects happening, and they get a lot of attention. There's a lot of learnings we can take from them. But as Autodesk, as a technology provider, we look at this and we say, this is great, but how do we make it standard practice? How do we go from the most sustainable buildings today to most buildings being more sustainable? In other words, there's a tremendous opportunity for, the sort of more typical design projects to have significantly greater levels of performance and value to their owners and communities and stakeholders. And it spans everything from materials to energy to water to you name it. There's a range of impacts. Energy is obviously a key cornerstone in that, and I'm going to focus on that a lot today. That's my particular background and interest. But I'm going to try and give you a sort of broader view of things a little bit as well from Autodesk perspective. And not everything has a direct line to sustainable design, because of course just better design tends to achieve higher sustainability. I will be highlighting that. But it's just one thing I want you to keep in mind is the fact that our goal and over your future careers, you're going to touch hundreds or maybe thousands of buildings, and the more you can touch, the more impact that you can have, the better. And that really needs to scale across many more buildings, and including even existing buildings, and not only these very high profile projects, which are important and great, but just remember the opportunity is the remaining 99% of the market that has significant growth potential and so on. So I'm going to start up with just a mental model, if you will, that you can keep in mind of, again, where we're at as an industry, and Autodesk as a technology company, and you as future practitioners, where we're at with respect to the evolution of technology and around this notion of building intelligence, greater insight into building performance, to achieve higher levels of performance, what that technology evolution looks like, and to recognize that for different elements of design, build, operate, there's different levels of sophistication and evolution that we're at, and there's a real mix of things. And I'm going to be using this sort of context of varying levels of technology evolution and different stages in the design process to sort of as the context for my presentation here today. So to go back quite a bit in time is something everybody is still familiar with. It's a very human thing. It's just manual drafting. And there was a time when all buildings were, created this way. It was very time consuming. Essentially all of the knowledge that it took to create a building resided in that person's head, right, or in the head of design teams. And changes were very hard to make. Mistakes were made, and still some great buildings were built, still standing to this day, of course. But what happened then was obviously pretty clear, is that the evolution of CAD essentially mechanized that process. It removed the pen and paper from the process and allowed it to be digitized. That greatly improved the productivity and to some degree the quality of the outcome, because of course the more you can handle changes and so on, the more you can explore designs and so on. But it was framed as computer-aided drafting or design, but in fact the computer wasn't aiding you too much any more than purely in the same representation of design intent. It wasn't necessarily actually helping you achieve better outcomes. That's quite a historical photo there, just for anybody who's interested. It was actually the very first version of AutoCAD that was released to the public. So that's pretty a piece of Autodesk history there. And then just very broadly speaking, then along came BIM. Now I here have a screenshot of Revit, and I'm not pretending to say that Revit is BIM. That's a whole argument that people go along. But what I'm really kind of saying is that going from 2D representation of anything as a series of lines or shapes, BIM was more object orientated, and the idea of a single three-dimensional model to coordinate everything. Revit really was the trailblazing thing there that changed the AEC industry around that, and it's very, very common now. It's more or less de facto in architecture in many places, and increasingly so in engineering and structural design, which I'll get into a little bit. But this was a giant leap in many ways, because going from single sort of 2D, coordinating 2D floor plans and sections and elevations, if any of you ever had to do that, you'll understand the challenge that it was and the mistakes that could occur between them. Of course, the benefits of a single integrated three-dimensional model essentially eliminate all that. You change any aspect of the building, all of your plans, sections, elevations, bill of materials all gets updated. So it was a very significant improvement on the process. And then that evolution is really in the sort of like past 10, 15, maybe 20 years, approaching 20 years now. But in the last few years, of course, just to broadly characterize it, the major impact has been the cloud. And this has really facilitated the evolution of BIM and tools like Revit way beyond what they are originally perceived to be as, Windows desktop tools that allow you to do drafting. And this, as many people say, the cloud really does change everything from the ability to connect all of that data to different stakeholders and to automate certain things. It really just explodes the whole notion even further beyond what a single building information model can do, because you can talk about city level and system level. The possibilities are endless. And then in terms of the big, probably the single biggest impact or potential impact from a technology perspective, and where everything here, where this evolution is ultimately heading towards, is ultimately the development of artificial intelligence for AEC. Sorry, for some reason my screen is freezing here, but let me just see if it'll move on. It's probably moved forward. So there we go. It moved forward 3 screens on me. So there we go. I'm back to where I was. Yeah, so ultimately, that's where a lot of things are heading, and different people feel differently about this. Some people have a certain fear of AI. We don't view it that way. It's not seen to be something that's going to replace the human in any case. You're always going to need humans to make those more nuanced decisions and make sense of the data, but we see it more as an assistance. And the point to think about here, as you look at everything here today, through the lens of sustainable buildings and sustainable buildings, how they're designed, how they're built and operated, there are a range of technologies available today at varying degrees of sort of evolution, and there's a range of workflows at varying degrees of evolution, from still in many ways quite manual to completely automated and machine driven. And we've got an abundance of technology to take advantage of to help us build better buildings. So that sort of sets the sort of overall context. And I'm going to be sort of telling the story of design to operate through the kind of like going from the sort of not quite far as back as the manual drafting. But remember, even in Revit today, there's still a bit of sort of manual modeling, right, that you have to do. It's not with a pen, it's with a mouse. But you should get the idea of what I'm trying to describe here, in terms of the fact that different tools, different workflows have different degrees of these characteristics across the whole design, build, operate, and it's taking advantage of those that allow us to and offer the opportunity to deliver significantly higher performing buildings. So I'm going to start the story in design, and I'm going to start with BIM. It's sort of in the middle of that picture, if you know what I mean. It's a good place to start because it's a very familiar place for everybody here to start, and it's a very familiar place for Autodesk to talk from because we've got a lot of strength in this area, right? And that's really to talk about Revit, okay, and talk a little bit about really the history of that. Revit actually started off as really an architectural model, where from a single 3-dimensional model, you could create and coordinate all other aspects of architectural design and documentation. So floor plans, sections, elevations, renderings, detailing, schedules could all be coordinated from a single model. So for example, if you deleted a window from the 3-dimensional model, you would see it in all other views reflected, and you would see your schedule have updated. And this has really revolutionized what we call traditional design, because it has allowed firms to become significantly more productive, handle larger projects with less numbers of people, or conversely, and in many cases, improve the quality of what they're actually delivering, meaning that, when it's closer to what the owner ultimately wants, there's less change orders and so on. And this continues to be a major area of investment for Autodesk to see how it's evolved from this. Remember, I think Revit goes back to early 2000s. What essentially happened, and today really there's almost no architects you talk to, certainly in the US and in many other countries, that are really not using Revit today as their core design and documentation tool. But following the success of that, Revit architecture was then essentially sort of verticalized to go into multidiscipline support. And this is really where Revit is at today. You don't really see people using Revit standalone anymore. It really works this way, where yes, you have a single coordinated architectural model, but that is being run in parallel with a structural model and an MEP model, all of which do the same thing. So, for MEP, you've got ductwork and pipework, you've got schedules, you've got plans, you've got sections, you've got elevations, you've got cut sheets, all of that being coordinated so that when a wall is moved in the architectural model, you can see if there's a clash or if it changes volume flow rates or size of supply grills or whatever it might be. Similarly on the structural side. And of course, the way people are actually leveraging this today is really over the internet, either a LAN or a WAN. So you'll have multiple project teams, very often, different organizations, architecture design firms, structural MEP design firms, all in separate locations, potentially even separate countries, often separated, other sides of the planet, all being able to work off a single building information model. And again, it is greatly, that multidiscipline support and coordination has greatly improved coordination and the quality of the end building product. And to go one step further, again, sort of speak of the evolution to a degree. Typically in the past, doing that sort of coordination of three fundamentally different disciplines across a LAN or a WAN required quite a significant investment in IT, specialist IT support. One project could have like 2 or 3, administrators on it, IT administrators full-time just to manage that. But that's becoming increasingly easy now through tools like collaboration for Revit, which essentially just hosts all of that in the cloud, meaning that anyone of any size can coordinate and collaborate with others of other discipline to help deliver higher performing buildings. So it's a really significant evolution. And so hopefully that gives you some idea of the evolution of just Revit itself from its architecture background to include structure and MEP, and to go from sort of standalone usage into shared right across the world on the cloud. And that really is, this represents how, the vast majority, virtually all of our customers in professional environments consume and use tools like Revit today, doing their daily business of design and production. So to move on, so that paradigm is very well established and continues to grow. But what we're increasingly seeing now is the evolution of BIM from design and production of drawings into the use of the building information model to actually build the building. So contractors are using it more and more. This is generally what we refer to as BIM 360. That's becoming a more broad, encompassing term for many more things now. But a way to imagine it is just to take all the value and the rich information that you can author in tools like Revit and make it much more broadly accessible to the actual contractors and boots on the ground actually building buildings, of which there are many more people than there are, designers. Contractors generally greatly outnumber designers, and their need for information is critical in terms of delivering the design intent. So tools like BIM 360 Docs provide that, because you don't necessarily have to have Revit to consume that information. You simply need a web browser, and you can get all your drawings and your sections updated over time. All of this information, of course, helps with programming on site. There's some very cool stuff you can see about how contractors actually coordinate the construction over time, delivery of materials on site, the laying of foundations and framework, and then, facade and systems, and all that programming and sequencing is a critical part to optimizing and reducing costs on site and efficient execution, and making sure that the building is built, on time and on budget. And then increasingly, a lot of the information that's available in the BIM model is used for asset tagging, so that when the owner ultimately takes ownership of the building, they can actually use that in the management of the building. And everything you see there, all of the information that's contained in Revit and in BIM 360 Docs and in the management of the on-site is being increasingly processed by something we call BIM IQ, which is our machine learning algorithms that essentially analyzes all of this information on a project-by-project basis for people and helps identify areas of opportunity for saving. So we're moving rapidly beyond reliance on humans to identify problems or potential opportunities for savings and so on, but purely the intelligence that exists in the data itself, Like, for example, certain contractors in certain regions or in certain stages of projects, we're able to identify certain problems that we're able to get ahead of and improve efficiency. So this is an area where we're seeing a great deal of value being created, and a critical piece. You know, I talk a lot about, you know, you can design the most sustainable building in the world, but very quickly you can not build it, right? Because if build quality isn't up to standard, it's not going to perform as a sustainable building or as designed. And then, of course, even if it's built that way, it's not necessarily operated that way, which I'll get to in a little while. And then increasingly, some more things which I'm sure you're all familiar with that are at the bleeding edge now of technology development that are starting to leverage off this rich information and open up new opportunities of areas around augmented reality and robotics. And there's just some very cool things happening there that are just, again, radically changing the ways in which buildings are actually being built. And we refer to it as industrialized construction generally, to look at those sort of almost factory-based methods being applied to construction sites. So when we move on, obviously beyond build, we're then into operate and into facilities management. And this is really in most buildings where rubber meets the road, right? Where, you know, you determine whether this building that you designed and built as a sustainable building actually operates that way. And we have a tool called Building Ops, which again takes a very different approach to the process, which actually puts the tools in the hands of both the occupants and the maintenance people on site, access through mobile devices to be able to allow occupants to report, you know, conditions in the building, as well as provide maintenance people with their to-do list, and critically, not only their to-do list, but link that back to the building information model, link their tickets to the assets and the documentation. You know, like, for example, a room is overheating, the fan is broken. Where is the fan located? What type of fan is it? You know, how do you repair it? Where do I get spare parts? Having all of that information at hand. I mean, very often we hear, you know, part of the challenge in maintenance is just finding where the piece of equipment is. So there's a huge amount that can be done to greatly improve the efficiency of maintenance, which invariably improves the quality of occupants' environment in the building, and of course the degree to which the building is operating efficiently. So that pretty much concludes the sort of like the lay in the scene of the whole design, build, operate continuum, as well as to thinking about the different tools that Autodesk have and the main sort of tools that are out there. There's many, many more in there that I didn't mention, and the different degrees of sort of sophistication and the rate of evolution and sort of levels of evolution that you've seen. You've seen a variety of samples, and I'm going to dig into a few more in particular. So what I'm going to do now is I'm going to jump sort of back a little bit, back into design, and back particularly into around sustainability and energy performance of buildings and the carbon emissions of buildings. Now, at Autodesk, we are big fans of the Architecture 2030 Challenge. There's a couple of reasons for that. Mainly is that, in fact, out of all of the different environmental initiatives that exist, we all know, of course, the major impact that buildings play on both, you know, raw material consumption, energy consumption, and carbon emissions. But what's great about the 2030 Challenge, it sets a very clear set of goals that can be adopted anywhere in the world and are more easily measured and proven, not only in design, but also in operation of buildings as well, because we can compare against peer data sets and so on. And what it actually calls for is a series of increasing targets to reduce the carbon emissions of all new construction, major renovation of buildings by 2030. Okay. So it's a very clear call to action, and the industry has really embraced this. We're seeing many of the large A&E firms have committed to this. One of the reasons we know that is the fact another initiative that we're big supporters of is the AIA 2030 commitment. And sometimes people confuse those two things, but what the AIA have done is they've recognized the value of the 2030 challenge and have asked not only their members and organization firms to sign up to, but anyone really who is willing to commit to the 2030 challenge, to sign up to the 2030 commitment, which essentially asks them to not only achieve the 2030 challenge, but also do annual reporting on your progress towards those goals. And this is critical because it's one thing to say that you're committing to things and to, be achieving for a goal, but we all know that, metrics are critical, measuring things are critical. And the AIA have been doing this for 7 years now. There are over 450 firms, not only architects, many engineers as well, signed up to this. And what we can see here relative to the 2030 challenge, which as you can see every 5 years is going up, you can see how we as an industry are doing. And you can see, it's maybe a little hard to see in this data, but there is starting to see a gradual uptick in the last few years, getting closer to this target. And there's a couple of things to point out about this. First of all, people sometimes think that if you're not hitting the 2030 challenge, you are failing. And that goes back to this: if I'm not building one of the world's most sustainable buildings, I'm failing, so therefore I won't do anything at all. That's completely the wrong perception to have. Because what the AIA and many people recognize is that the industry needs to transform towards a low carbon approach to things. And that's what this is really trying to encourage and enable. And we can see this transition taking place. Now, there's still a great deal of work to be done, but the great thing is we have data that's actually able to track this. And every year, the AIA produce an annual report that sort of talks about this and where this data is coming from. It's all over the world. It's not just the US. It's not just architects and so on. Granted, it is still not a representation of the entirety of the industry. There's still many more people not signed up to this, but that's changing as well. More people are signing up and more people are increasingly reporting. But this does at least give us, for the first time, some sense of a trajectory towards that. One of the things that the AIA say, we're obviously great supporters of this, but to quote the AIA so that you don't have to believe me, right, is the fact that they continue to say that energy modeling is the key to meeting the 2030 challenge. And there's a number of reasons why they say that. So there's a very significant push for energy modeling to become more and more integral part of that process. And that's something that Autodesk has been working on for many years. And that's what I'm going to talk a lot about here today, and you can kind of see again how it fits into this picture of evolution, because even with what we've got today, we're continuing to always improve, and that's what I meant to remember. So it's not about sustainable buildings, it's about more sustainable buildings. Just the same way as we have, great software today, we want even better software tomorrow. So we continue to work on that sort of continuous improvement. So where does this sit? So, to go back to our kind of storyboard again, we have building information modeling. That's a really integral part of the design process today. But in reality, building energy modeling is actually not an integral part of the process. Certainly, many signatories of the 2030 commitment are doing more energy modeling. But on average, it's maybe 25% of projects. So it's still the exception, not the rule. We've researched this area very significantly over really the last 10 years. It's really the last 10 years, Autodesk has done a lot of research and development in the area of building energy modeling and developed a number of tools and features that some of you may know from the past, and some of them good and some of them bad. But we've made very significant improvement. But really, all of that has been driven by feedback from the market and the industry and practitioners about what it is about existing kind of building energy modeling. In other words, given the fact that the AIA recognizes, and everybody recognizes, the significant opportunity that building energy modeling has, why is it not more an integral part of design? And these are just some of the things that we hear, some of the most common comments or barriers that we hear from a variety of people around why energy modeling is not a typical part of the process. And when I say energy modeling, I mean energy modeling has been around a very long time. Some of the core engines like DO2 and Energy Plus, they go back like 30, 40 years of history of development, and they continue to be developed. But in many ways, their fundamental form and the way in which people employ them in the design process and the building life cycle actually hasn't really changed. They've gotten better over time at greater and greater precision, but you'll see in many ways there's other things that they're not serving. Now, I don't mean to say that the tools that are out there today don't have a role and a place. It's just that they're not fulfilling all needs for all people, because in reality, they have not scaled in the market. Remember, they're still not an integral part of the design. And our goal at Autodesk has been to change that, to make them an integral part of design. So the barriers we hear is, it's complex and time consuming, and I don't have the time to do it. It's very difficult to apply at early stages. Most tools and workflows only really work at a sort of detailed design, CD level, documentation level. Otherwise, there's fear that they're wrong because there's too many unknowns. Big challenge in the past is that you need a whole separate model. You know, a building information model and a building energy model are two fundamentally separate things. It's not just a matter of transforming like two different CAD formats. It's a fundamentally different representation of building geometry, which normally takes time and skill to create, which people don't have on every project. We often see as well that they're very much driven by code compliance or things like LEED and so on. Again, code compliance and LEED, they have their role and their place, but they only represent energy analysis or the use of energy modeling or simulation in one form. And it's not the only form that's possible. Similarly, it's driven a lot by mechanical engineers because, you know, most of the tools that are available today are heavily orientated towards HVAC system simulation, which is great and really valuable. But in that form, it tends to be less clunky, a lot more clunky for other purposes, especially early in design. And finally, we hear, and you see this documented a lot, people often ask, you know, can I trust the data, and, you know, how accurate will the simulation be relative to the actual building? Or what they find is that when the building is built and operated, the building uses a very different amount of energy than what the energy model says. And unfortunately, people often blame the energy model because of that. But in reality, it's been proven over and over that energy models, given the right inputs, the right description of the building and how it's operated, they can actually achieve very high levels of accuracy. They can represent physicality and the physics of building very, very well. The reason for discrepancies and the reason people don't trust them is often because it's just a matter of unknowns in the design process, and things change, things get value engineered, buildings are not operated the way they were intended to be designed, and there's no good way currently to manage those different risks and the way information has changed. And then finally, the one that pains us the most and that we're trying to change is that energy modeling is only for engineers and projects where budget and time allows. We want to change that. We want to make energy modeling available for, I won't quite say everyone because it's still reasonably technical, but we really want to improve the, how do I say it, the familiarity people have and the understanding people have with why buildings use the energy they do and how to make them better. And we want it to be possible on every project. So based on that, that's really what led to the development of Autodesk Insight, which is our, you know, building performance analysis suite of tools, which are, you know, part of Revit. So if you have Revit, you have these tools. And these are just some of the areas that, you know, Insight is fundamentally different from the existing tools. And I'll get into this a little bit more with some actual examples. But unlike existing tools, which are very successful at allowing you to run an analysis or create a model, but that in itself, if you think about it, is not the goal. The goal is ultimately to get a better building, and to get a better building, you need guidance. So we describe Insight as providing clear, optimal guidance. And optimal meaning two things, right? Optimal in terms of a better building, but optimal also critically being better building based on the constraints of the available time and information that you have. That's a very real constraint because in the design process, those two things are often in short supply. So given those constraints, how can you still provide a lot of value, and how can you provide the right kind of guidance to design teams to focus in the right areas and to make the right decisions? Critically, unlike other tools which only really operate at a single level of precision or stage in the process, Insight scales right from the very earliest stages in design, conceptual design and massing, all the way through to detailed design. And we can even apply it to the operation of existing buildings to help look at opportunity for deep energy retrofits and things like that. Underneath the hood, as much as we've worked to make it as easy as possible to do this analysis, we have not compromised accuracy either. So we're using all of the established and well-trusted industry-leading simulation engines like DO2 and Energy Plus. And in addition to just using those engines, we're using some of the latest computational techniques in the cloud to really increase the value of not just a single simulation, but hundreds of simulations, even stretching to billions of simulations. Not actually running billions of simulations, but we're able to represent the equivalent of through a lot of innovative computational techniques. Critically, there is no separate model required. You know, this is a truly BIM-based workflow, so you don't need to say, wait, we need to go and create a separate energy model. If you have a Revit model or a format model, you have an energy model automatically. You just need to know how one is automatically translated into another. And then ultimately, what Insight ultimately does is that it takes energy modeling out of the engineer silo, and it makes it a much more collaborative process. Meaning, not only can the architect get more involved, the architect and engineer can collaborate together, and also can involve the owner to a far greater degree to achieve a better outcome, and ultimately better integration, better trade-off between systems and envelope and things like that. So that's sort of Insight explained at a high level and how it's different. And it's important to do that because, like I said, a lot of these tools have been around a very long time. If anyone has used these in the past, they have led to certain beliefs or paradigms that people hold to be true, some of which are and some of which are not. And Insight challenges many of them. It is very much a new paradigm, and sometimes it takes a little bit of a time to get your head around how Insight is different, and there's more to it than meets the eye. So what I'm going to show you now is just two of the really sort of core aspects of Insight. If you explore today around the modeling side, first of all, in Revit or Format. If you want to do an analysis, you need to have a building model, right? You need to have a project to analyze. And of course, Format and Revit can represent physical design or architecture in a variety of ways. People tend to think about it being this sort of on the right-hand side, this DD, CD level, very rich, detailed, three-dimensional model. But of course, you can start much earlier in the design process with something as simple as massing and levels. And something in between schematic, showing the really kind of core aspects of the interior layout and where you're putting windows and things like that. Some of the really key decisions around the building, very easy to do. So the point to make is the fact that Revit not only represents different ways to represent the design and go through the design process, it also supports a wide variety of modeling styles. And in the past, that was always a challenge for automatic energy model creation, because those features always relied on you creating the model one particular way at one level of detail. Well, that's not the case anymore. Very accurate energy model creation that spans this entire process from concept to schematic to detailed. Everything in between, supporting a wide variety of modeling styles with no requirements for you to clean the model or the model to be super watertight or anything like that. The only thing that it needs is the model to be what we call reasonably enclosed. And all that means is that there's no roof on the building. We can't assume you intended for those spaces to be heated and cooled, right? They're essentially outside. But what this provides is it's completely automated. There's really no manual effort involved. And the great thing is that the accuracy is actually very high, geometric accuracy. And so this is something I've been saying in the industry for a very long time now, but in the existing paradigm, if you had a physical model, some drawings or a Revit model, and you manually created an energy model, you took off room by room and you did zoning and so on. If you look at all the measures of what makes an energy model accurate, like area and volume and surface area, window area and so on, manual modeling is maybe accurate within around plus or minus 10%. And that's okay. Considering that you're probably going to use that model for comparative purposes anyway. But bear in mind, it's taking you a lot of time and skill to create that. You're still ending up with something that isn't entirely accurate. When you use a BIM-based approach like Revit, you get a much more accurate model. It's actually accurate within a couple of percent. So and it's free, right? It's generated automatically. So in addition to obviously creating that model in Revit and serving Insight, being able to use that for energy analysis in Insight, you can also export that model in a variety of formats, really the three main formats that the industry uses for energy modeling: data exchange, which is GBXML, DO2, and Energy Plus. Because, of course, we don't expect or think that Insight does all kinds of energy modeling for all people. It does a very particular type of modeling to solve a particular problem or set of problems. And for anything else, and for any of the existing tools and workflows like compliance workflows or detailed HVAC systems analysis, you can still use the Revit model and a lot of the Insight data to create that model and bring it into a third-party tool like eQuest or something like that. You pick your favorite. So we got this very high-quality GBXML, DO2, and Energy Plus files out of the back end of this for use in other tools. But of course, what I'm going to talk about here today is tools that Autodesk has to offer, and you can use as part of your sustainable design practices. And of course, Insight leverages that model. So what Insight does is it takes that energy model and it takes your location and it simulates it in the cloud. And some of you may be familiar with Green Building Studio. That's still very much there. The difference is that you can sort of imagine Insight as being a new sort of skin on Insight on GBS. GBS is still used to run and store the individual DO2 or Energy Plus simulations. You can see all that granular data in GBS if you sign into it. But what Insight does is that it takes those simulations that are automatically run, and notice I say simulations, not simulation. We're running a few hundred simulations, and what Insight does is it does an additional layer of computation on those simulations. And it presents the data in a very visual, graphical, interactive way. And this is essentially Insight here. So I'm showing a little video here. This is going to loop, so as I talk, it'll play around a little bit. So some of you may already have explored this. But what Insight does that's fundamentally different is that it provides an energy range. Other simulation tools, if you think about it, they provide a single simulation, and it's on you to know what sort of parametric runs to run and how to do comparison and create reportage around, you know, A or B is better. Insight fundamentally at the center of it is about comparison. That is the end goal. You need guidance. You need to be able to do comparison. And so the energy range is a product of the simulations that we run, which comprise every scenario. People often say, well, you know, what are the inputs to Insight? Well, in fact, everything is the input to Insight, because you take something like wall insulation or roof insulation or HVAC systems or lighting efficiency, you name it, all of the traditional inputs to an energy model like occupancy, et cetera, et cetera. We don't just put a single input, we actually put a range of inputs and we compute the entire range. So it is equivalent to actually getting the product of billions of simulations. And that fundamentally changes the way you interact with the data, because what you now have is an energy range. So you still have a number at the center, like here, $2.33, but you'll also notice that there's a minimum and maximum. And that minimum and maximum is really the product of the constrained range. You'll have the best of the best combination and the worst of the worst and everything in between. And the mean will be the mean. It's the middle, the weighted middle average of everything that you've selected. And what Insight provides is a very graphical and interactive way to see in real time the cause and effect of any individual factor of building performance. So you can see all of the different factors on the screen here, like lighting efficiency, operating schedule. And by moving the bar up and down, we can see immediately through the slope of the curve what the value of that measure is and what its impact on the overall performance would be, if it was at a high end of performance, low end of performance. And it allows us to work with as much or as little specificity as we want. In other words, certain parameters I just don't know. Like maybe it's a speculative office and I don't know the operating schedule. But in that case, it's better to encompass the uncertainty and actually optimize the building for a range of potential operating schedules, as opposed to optimizing it for a single artificial and by definition wrong point of performance. And so the thing to think about is that every time you're in Revit and you submit to Insight, not only are you testing your model, whatever's in your Revit model, you're testing that against a scale of other possibilities, which you can then use to represent other scenarios. Anything from super high performance to maybe you're analyzing an existing building and you're looking for retrofit opportunities. Take, for example, in those cases, you don't know exactly what the wall properties might be or the glazing properties might be. What this can show you is how important those properties are, and you can very easily approximate, you're in a lower performing range or higher performing range. And what this has actually proven, and I'll talk about in some of our case studies, is that although this method looks extremely simple and almost too simple if you've used any other tools in the past that allow you to get to a very, very granular and precise level of input, people confuse that level of precision with accuracy. That level of precision does not actually inherently give you accuracy. This method, however, does actually ensure greater accuracy because it is encompassing uncertainty and a range, and it shows you the role and value of individual inputs and drivers. So this is what we mean by it's a fundamentally different approach to energy modeling. And as I said, instead of the end goal being purely to run an analysis, it truly does provide optimal guidance to how to make a building better, and it does it very, very quickly. You need to do from the outset is apply your Revit model. So if you haven't already tried this, I would definitely encourage you to give this a go. You know, obviously, you guys have access to all our software, which is great. So looking beyond the energy side of things, Insight also covers a number of other aspects around thermal comfort, daylighting, photovoltaics analysis. So what you're seeing here is, you know, a visualization of the hottest and coldest parts of the building. This is moving faster than I'm able to talk. So again, this is going to cycle. What you're also able to see here is the ability to look at photovoltaic potential, solar radiation and insulation, which is great for shading design or detailed PV placement. And then, of course, daylighting as well, whole building or space by space or level by level daylighting simulation done with the native Revit model. So again, there is no need to create a separate daylighting model. It uses the whole Revit model and it includes all of the detail, should you wish, including things like curtain wall mullions and window frame and even furniture and so on. If you want to include that, you can. Again, normally daylighting is a reduction or simplification of the building's physical model, but there's actually none of that required in our daylighting. So Insight goes beyond energy. Energy is like a core piece to it, but like I said, peak heating and cooling loads, daylighting and photovoltaics are other critical aspects of overall building performance. That all of that information is available at your fingertips within Insight. And of course, a lot of this information that you see is directly available in Revit itself, and you're able to visualize the data in the Revit model as well. So again, I would, if you haven't looked at this before, I'd encourage you to check this out. So then just to talk about one particular example of a customer, and this is one of our largest and greatest customers, HOK. You know, they consistently are in like the top, if not the top three, always in sustainable design, and they've made tremendous progress in the last few years around this. And they have been looking for something that really allowed them to go beyond sustainable design and energy modeling being just something that, you know, some specialists in one office or one corner of the office could do, something that everyone on all their offices, on all their projects can do. And these are just some of the quotes from them around how they have found a lot of success with Insight. And some really nice ones here that, you know, now teams are running analysis for themselves really fast, you know, and they're not just doing it for the sake of it, because we saw a lot of that where people were running analysis, they were creating reportage, they didn't necessarily really understand what it said, or they weren't necessarily acting on anything in the energy model. Now people are actually using this analysis to make better decisions or to help justify why they are, say, bigger or smaller windows or greater shading or, you know, higher efficiency lighting or HVAC, and how that whole integrated design really yields a better building for the owner and help get that buy-in. Personally speaking, as an energy modeler and taking, you know, a lot of pride in the technical rigor of how we approach things, I really like this last quote here, where, you know, traditionally in the past, HOK, we're outsourcing a lot of their energy models. So what they did to compare Insight was that they resurrected 10 other energy models that they had done through outsourcing on other projects, which they had a lot of confidence in because they spent a lot of time and effort and money in making them as right as they could. And they were very quickly able to model them in Insight and compare it to Insight. I couldn't believe just how close they were, you know, within 5 kBTUs for their EUI in all cases. And they really felt that that was unbelievable. And it really reinforced this notion of accuracy over precision. Again, I'm not trying to make the point that existing tools do not have a place or have a role. They absolutely do when you need to, you know, assess the impacts of a certain decision at a certain level of precision. But what Insight does is still able to achieve a very high level of accuracy. In other words, the outcome will match the overall what the tool is saying, with very little effort. So that's really great validation from our perspective. And there's many more of these as well starting to come online. If you watch our blog, we cover more about what our customers and out in practice are doing. So I'm gonna jump now from focusing particularly on Insight and the design energy modeling, the operational into the operational piece, because our story continues. Remember that there are far more existing buildings than there are new buildings being built. There's tremendous opportunity to do retrofit and make existing buildings more sustainable. And we've got a variety of tools and a number of projects, a number of technologies that are helping to really deal with this. And so the first one is in capturing existing conditions. And that can be as simple as satellite information or GIS information, being able to automatically create city or portfolio level models, which can then be used to run individual building energy models and help identify buildings with high potential for deep energy retrofit, as well as starting to leverage photography and laser scanning information for point clouds to create very detailed Revit models. Look at this one is crazy. This is an amazing building. Autodesk Consulting did the project laser scan of the U.S. Air Force Cadet Chapel, a historic building, incredibly geometrically intricate. And from that point cloud, we're able to build this very detailed Revit model from which we can create a detailed energy model, do energy modeling, daylighting simulation, et cetera, et cetera. And then increasingly, I'm just going to wave my hands here a little bit because this really is one of the new frontiers around just the Internet of Things and just sheer availability of more and more data, whether that be weather data or thermostat data, or how a blind is operating, or energy meter sensoring, or you name it. There's more and more data available to close the loop on building performance, and we're seeing more and more of that happening in faster ways. On the energy side specifically, of course, we are doing a number of projects to sort of tackle this. So you'll see large projects like we're doing with the DoD on tackling their portfolios to help them understand building energy use without having to do on-site audits and things like that. And we've also got Dasher 360, which are ways to visualize energy use in buildings, environmental conditions using the building information model. And then just to step back and look at the entire continuum of design, build, operate, an increasingly growing area of development and usage that we're seeing that spans all aspects, design, build, and operate, is really visual programming and computation. And the example I have here is, as you all know, tools like Revit, even going back to AutoCAD and things like that, have always have and continue to have APIs to them. And in the past, that always required a software development type persona to be able to do anything with them. Well, tools like Dynamo allow non-programmers to actually start to control not only building information models, but any source of data or other tools to create their own programs, basically, and make the models do things that they don't normally do out of the box. Because, as a software company, there's only so many things that we can build. And in many cases, people can go the extra mile to solve, certain particular project problems or certain problems that a certain market needs, and so on. So again, this is an increasingly growing area of adoption that we're seeing in the industry. More and more visual programmers really become an integral part of every design team now, and many design practices. You can do all kinds of cool stuff. I just want to give two examples here. Not only it's typically sort of positioned as doing a lot of very high-end, curvy, swoopy architectural geometry, but it can also be used in very, very sophisticated and integrated manufacture of things. This is an example of a bridge in Amsterdam that's actually been 3D printed by robots. And that bridge design is actually developed, and the programming instructions were developed using Dynamo. So some really cool stuff happening there. Just again, the possibilities are endless, really, when you take all the tools that I'm sort of showing and you put them in hands of people who can go beyond what we provide through a simple user interface, put data at the center, allow people to customize and mix them with their own things, and just all kinds of possibilities. That really brings us to a sort of core strategy of what Autodesk is doing around something you may have heard around Autodesk Forge, which is really taking all of our IP, the 30, 40 years of IP, and making it available in the cloud as a series of services. So again, people can build on top of what we've got, leverage the data that's created, leverage their own proprietary data to solve their own company or enterprise problems, as well as develop innovative solutions that can be taken to market and provided to market at a much broader context to any Revit user, any AutoCAD user, you name it. And so this is a very cool area of development. And then at the really bleeding edge, we talk about generative design and how the future goes way beyond the typical sense of documentation. And this example, again, an Autodesk project that we did with Airbus around the generative design of this particular part of an airplane, where the optimum strength and weight was determined through hundreds of thousands of simulations. And the end product being, as you can see, that design, that configuration, that physical configuration is not something that any human being would arrive at normally. There's just far too many individual trial and error exercises you would have to go through to arrive at that. You'd come up with something much more typical, using typical structural engineering approaches. But using generative design and the ability to explore every option and combination yields solutions that humans wouldn't normally think of. And this is where we see examples of machine learning and computation really supporting engineers and architects in better ways, and not leaving it to chance or their instinct or their, what they did on the last project. We're really able to drive towards better buildings. And in fairness, this is a fairly straightforward exercise in terms of optimizing for strength and weight, but we're taking these principles and applying to more complex problems like building design and facade design, window to wall ratio, shading, glazing properties, and so on. So this is something called Project Fractal, which you can see a little prototype, the Skunkworks project of how it works with Insight and the energy cost range, where it is literally exploring every possible combination within a set of constraints around different glazing and shading options, and it is finding the optimal solution based on those constraints. So again, it takes the notion of just a single simulation and just completely blows that up and allows people to really use the tool for their intended purpose, which is really to find optimal solutions, not just essentially analyze a single arbitrary point. You see more of that development here around things what we call Project Quantum, which is again another internal project. We've been talking about more and more the ability to create and connect more and more parts of information. Now, this particular example is specific to do with energy analysis. What you'll see here is from the moment you start to model in the building, all the performance information around energy and daylighting and carbon and comfort all automatically update. And this is leveraging not just, building information modeling and computational design and simulation and all the weather data that we have, but it's also leveraging things like machine learning, regression models, and things like that to provide this all super fast, real time feedback on design. So this is sort of like giving you a little insight into like the next generation of tools, which are really being built on the tools that we have today. And we're just, continuing to make those investments that push the boundaries on what's possible and start to solve more and more of the problems that people continue to ask about. So then that really swoops me back around to the end to sort of say, hey, what is the purpose of all this all? And if any of you I'm going to leave us on a personal thing around Insight, and if you go to the website, you'll see our tagline. The company's tagline, Autodesk, is to make anything, and we talk about make the built environment better. That's ultimately our goal, and hopefully everything I've shared with you today gives you kind of a whistle-stop tour of everything that Autodesk is doing in the space, the tools that are available to you today, and the direction that we're going with in the future, all for this reason, right? And none of that matters if people don't use those tools. Like I said, I really encourage you to try the things that you've seen here today, ask questions, contact us, look at all the learning resources online. And on the last slide here, I've just got, and you'll get this sent, a hard copy of this presentation, which will have all the links. So particularly if you want to explore Insight, these are all of the learning resources for Learning Insight. Each one of these is a hyperlink which you can use to get started and be successful with incorporating Insight into your learnings and your projects.
In addition to the learning resources that Ian mentioned, let me also mention some additional ones. Autodesk is passionate about helping you to inspire, engage, and prepare students for academic and career success. So through our Autodesk education community, students and educators have free access to individual downloads, and institutions have access to network licenses of Autodesk software. In addition, the Autodesk Design Academy community helps educators introduce students to the world of design and construction with free hands-on supplementary projects and course materials that promote critical thinking and problem-solving skills. We recently added student-led, self-paced online learning courses to support a flipped classroom approach to cater to different kinds of learning styles. One of our programs is the Building Performance Analysis Certificate. It's a free, online, self-paced educational program designed for architects and engineers who want to learn how to incorporate high-performance building design into their workflows with Autodesk tools. The BPAC certificate comprises 7 modules, anything from building performance analysis, climate and weather, solar, wind, daylighting, and whole building energy optimization. BPAC uses the latest Autodesk Building Performance Design software tools, integrating performance feedback directly into the design process. It has quizzes and exercises that challenges you to reflect upon your knowledge. In addition, these are just a few of the course titles in our Autodesk Design Academy community that you should check out. Anything from reality computing, introduction to BIM, and conceptual design collaboration. So next steps, I encourage you to download Revit and/or Format desktop software from the Autodesk Education community, so you can use that as the input for Insight that Ian covered today. Next, check out the learning resources mentioned in this presentation and download and enroll in the curriculum from the Autodesk Design Academy. So with that, we'll move on to the questions and answer period. So while you're thinking of questions, let me start Ian off with a question while I also skim the question board. Going back to your point of increasing accessibility to many stakeholders from, say, the perspective of an engineer, how can the engineer leverage the use of Insight? And maybe you can answer this question. Insight is a collaborative platform, is it not? Where you can invite multiple stakeholders to see that information and interact with it.
That's correct. Yeah, it is web-based, right? So you need Revit to generate the models, and not everybody has access to Revit, of course. But once those models are generated, all that data and Insight itself is web-based, and you can share a link to the Insight. It's like a gallery type space. And people can get access to that, and they can explore around. And the results can be set up in a way to kind of tell a story, and people can poke around for themselves and see the impact of higher or lower operating hours or higher or lower efficiency XYZ. And you can always reset it, so people can't do any damage to it, if you know what I mean. They can't undo the model. It can always be reset. So yeah, it's a highly collaborative environment, and we really encourage people to do that. We see people a lot of the time taking screenshots and exporting graphics to build static reports. And that misses an opportunity to have a much richer conversation with people. I'm going to answer the question about the engineer, because they're really well suited to doing this. And the short answer to the question is, how can an engineer leverage it? It's actually the same way that an architect, initially, it's the same way that an architect can leverage it, because if you look at Insight, yes, it is primarily, but not exclusively, aimed at architectural issues, i.e., it's really strong at looking at things like orientation and building form, window to wall ratio and shading and glazing properties, as well as all the other systems related pieces. But any engineer knows that some of those critical decisions that are made early on have a major impact on the efficiency of those systems. So if there's nobody on a project using it architecturally, the engineer can fulfill that need to propose ways to look at the building a little bit better, make improvements to the envelope, add some shading where appropriate, minimize internal loads. That whole story that engineers normally try to convey to owners and architects, let's design an efficient form so that we make it easier for the systems to be efficient. They can use Insight for that. And then, of course, once they go beyond that, maybe they're working with an architect who's already doing, but like I said, if they're not, they can do that. Once they go beyond that, of course, what Insight provides them with is actually a framework for their deeper energy model. So they can take Insight, they can take the GBXML, they can export it to their existing tools, they can do their more detailed systems analysis, and they can compare Insight to it. And you can essentially put the same inputs, similar inputs to both tools. It takes a little bit of understanding to how to do that. But you can essentially compare apples with apples, and what Insight provides then is a a faster, simpler sort of picture of the project's performance without exposing all of the guts of the detailed simulation necessarily to everybody. So like I said, an engineer can use it as a communication tool just as anyone else can. The two things they cannot, let me be very clear, that they can't use it for, they may be disappointed to hear, but we're not trying to replace those tools. They can't currently use it for detailed HVAC systems design. They can't say, oh, I'm going to use, this is going to help me design between a VAV or a fan coil, or let's say, even if they know the system type, two different chiller sequencing options or something. That's what tools like eQuest are for, and they're great at. The other thing it won't provide you with is code compliance documentation. Again, existing tools do that. If you're doing lead or something like that, you can still export and do those baseline models and do all of that. What Insight is really intended for is a single place that shows you why the building will use the amount of energy it does, how to make it better, and manage the design opportunity and operational uncertainty all the time. And anyone can take advantage of that.
Super. If I could ask one more question, then we'll close out. Is it possible to leverage Autodesk Insight before you even think of your first design concept to better understand the environmental conditions of the location you're designing for? So can we leverage Insight to inform preliminary design strategies?
Yeah, absolutely. That's a great question, actually. Let me start by saying, unfortunately, most people leave it far too long to do analysis. They wait until they're the, DD level almost. Certainly relative to an energy model, like a very detailed, building shape is decided, where you're putting windows is decided, et cetera, et cetera. People leave it too late. In reality, the building's shape, its form, its geometry, its massing, its orientation is just one of a number of factors that drive building efficiency, right? It's obviously a key one, just like the others are all key as well. But just because you don't know it or haven't decided it doesn't mean you can't start to understand the opportunities in the other context, because you've got your local climate, you've got materials, you've got, lighting efficiency, equipment efficiency, hours of operation, PV potential, all these things. So we really encourage people from day one, if you haven't decided the shape of the building, simply just draw a box, put in as many levels as you know, represent it in the simplest form possible. Because what Insight will then show you is the role that each aspect other than the building geometry will play around extent of glazing and shading and, like I said, all those factors, lighting, efficiency, schedule. And you can very easily, from day one with a box, set out what we call targeting and feasibility. In other words, if a client has, or you have a goal of net zero or architecture 2030, you can see what it's going to take to achieve that. And then once you set those constraints, like you're going to have high performance glazing and shading, et cetera, et cetera. As you then start to formulate different design options around massing, you're going to see within those constraints which design options do better or worse within those constraints. And you get to see, use that to guide the design. So absolutely, that is a critical thing. And that's what we really mean about Insight being scalable, applicable from conceptual stages. The earliest representation you have of the building massing. And if you go back to that Revit example, notice I hadn't even modeled any windows on that Revit model yet, the box, the one on the left-hand side. And that's a good thing, because we want to actually understand what role will window placement play in the overall building's energy performance before I start placing them. So that's a really good question, and the answer is yes.
Super. Well, Ian, thanks for a fantastic presentation, and thank you again for your responses. And so just as a reminder for the audience, today's recording will be posted within 3 business days, and you will receive a follow-up email from GoToWebinar with the recording link. So in summary, you heard through Ian's presentation why it is important to consider the Design Build Operate Lifecycle as part of your design strategy. And with Design Insight, you have the power to make better buildings. This concludes today's presentation. Have a great day.